What is the inverse of a function? The inverse of a function tells you how to get back to the original value, and it is denoted by this, which is read as the inverse of f of x. It is obtained by swapping x and y coordinates of the original function to y and x coordinates. Example, R is equal to the set of ordered pairs -2 and 4, -1 and 1, +2 and 4, +3 and 6. If we will write the inverse of the given function, it is now written as the inverse of R equals the set of ordered pairs 4 and -2, 1 and -1, 4 and +2, 6 and +3. Notice that the y values became the x values, and the x values became the y values. If we try to observe the inverse of the given function, it is not a function. With this, we can now say that these two functions are not inverse functions. For our next example, we have S equals the set of ordered pairs -2 and -8, -1 and -1, +2 and +8, +3 and +27. If we are to write the inverse of the given function, it will be written as the inverse of S equals the set of ordered pairs -8 and -2, -1 and -1, +8 and +2, +27 and +3. The y values became the x values, and the x values became the y values. Try to observe the inverse of the given function. The inverse of the given function is a function. And this tells us that S and the inverse of S are inverse functions based on the set of ordered pairs which we took their inverse. Do all functions have an inverse? The answer is no. Not all functions have inverse. Functions that have inverse are one-to-one functions. This time, let's try to find the inverse of a function given an equation. For our first example, we find the inverse of f of x equals -2x. For our first step, we replace f of x by y. So f of x equals -2x is now written as y equals -2x. Next step, we swap x with y and y with x. So x is now equal to -2y. For our third step, we now solve for y in terms of x. To isolate y, we need to divide both sides by the numerical coefficient of y, which is -2. So x will now be divided by -2, and -2y will be divided by -2. x divided by negative 2 is equal to negative x over 2 equals negative 2y divided by negative 2 is equal to y. Or we may write it as y equals negative x over 2 using our symmetric property of equality. For our next step, we will now change y to the inverse of f of x. So, the inverse of f of x is equal to negative x over 2. We try to check if y equals negative 2x and y equals negative x over 2 are inverse functions. And we are going to use the composition of function. It is written as f circle inverse of f of x is equal to negative 2x. We now replace all x by negative x over 2. Our composition is now equal to negative 2 times the quantity negative x over 2. Negative times negative is equal to positive. 2 and 2 can be cancelled. They will now become 1. 1 times x is equal to x. The denominator of negative 2, which is 1, times 1 is equal to 1. So f circle inverse of f of x is equal to x. This time, we solve for the inverse of f circle f of x, which is equal to negative x over 2. We are now ready to replace all x by negative 2x. The composition is equal to negative 2x over 2. Negative times negative is equal to positive. 2 divided by 2 is equal to 1. And the remaining term is now our final answer. The inverse of f circle f of x is equal to x. X is equal to x. We can now conclude that the inverse of f of x, which is equal to negative x over 2, is the inverse of the given function f of x equals negative 2x. We proceed to our second example, which is to find the inverse of the given function g of x equals 3x minus 1. So we replace g of x by y. G of x equals 3x minus 1 is now written as y equals 3x minus 1. Next, we swap x with y and y with x. So we have x equals 3y minus 1. We now solve for y in terms of x. To isolate y, we need to transpose negative 1 to the left side of the equation. It is now written as x plus 1 equals 3y. Then, We divide both sides by the numerical coefficient of y, which is positive 3. X plus 1, we divide it by 3, and 3y, we divide it by 3. Y is now equal to the sum of x and 1 divided by 3. Next, we change y to the inverse of g of x. Inverse of g of x is now equal to x plus 1 all over 3. Let's check if y equals 3x minus 1 and y equals x plus 1 all over 3 are inverse functions. G, circle inverse of g of x, is equal to 3x minus 1. Let's replace all x by x plus 1 all over 3. Our composition is now equal to 3 times the quantity of x plus 1 all over 3, then copy minus 1. 3, multiply it to the quotient of the sum of x and 1, and 3 is equal to x plus 1, then copy minus 1. We now combine similar terms. The positive 1 combined into negative 1, it is equal to 0. Therefore, g, circle inverse of g of x, is equal to x. This time, let's try to solve for the inverse of g, circle g of x, which is equal to x plus 1 all over 3. We now replace all x by 3x minus 1. So our function is equal to 3x minus 1 plus 1 all over 3. We are going to simplify first our numerator. As you can see, we can combine negative 1 and positive 1, which is equal to 0. So the remaining term in our numerator is 3x. Then we copy over 3. 3x divided by 3 is equal to x. So the inverse of g, circle g of x, is equal to x. X is equal to x. Thus, the inverse of g of x, which is equal to x plus 1 all over 3, is the inverse of the given function g of x equals 3x minus 1. For our third example, we find for the inverse of h of x, which is equal to 5x plus 3. First, we replace h of x by y. So h of x, which is equal to 5x plus 3, is now written as y equals 5x plus 3. Next, we swap x with y and y with x. So x is equal to 5y plus 3. We now solve for y in terms of x. To isolate y, you transpose positive 3 to the left side of the equation. So our equation is x minus 3 equals 5y. Then, divide both sides by the numerical coefficient of y, which is positive 5. X minus 3 will now be divided by 5, and 5y will also be divided by 5. Y is equal to the difference of x and 3 divided by 5. Next, we change y to the inverse of h of x. So the inverse of h of x is equal to x minus 3 all over 5. This time, let's check if the two functions are inverse functions. H circle inverse of h of x is equal to 5x plus 3. We replace all x by the quotient of the difference of x and 3 and 5. Our function is now equal to 5 times the quantity of x minus 3 all over 5. Then copy plus 3. 5 multiply into the quotient of the difference of x and 3 and 5 is equal to x minus 3. Then copy plus 3. We combine similar terms. Negative 3 combined into positive 3 is equal to 0. So h circle inverse of h of x is equal to x. We now solve for the inverse of h circle h of x, which is equal to the quotient of the difference of x and 3 and 5. We replace all x by 5x plus 3. So our function is now equal to 5x plus 3 minus 3 all over 5. We simplify first our numerator. We combine positive 3 and negative 3. That is equal to 0. The remaining term on our numerator is 5x. Then copy over 5. 5x divided by 5 is equal to x. The inverse of h circle h of x is equal to x. Since x is equal to x, we can already say that the inverse of h of x, which is equal to x minus 3 all over 5, is the inverse of the given function, which is h of x equals 5x plus 3. For our fourth example, this is not a one-to-one function. So all we have to do is to get its inverse. We now replace f of x by y. So y is equal to the quotient of the sum of x and 1 and the difference of x and 5. Then, we swap x with y and y with x. X is now equal to y plus 1 all over the difference of y and 5. We now solve for y in terms of x. We multiply both sides by y minus 5. The difference of y and 5 multiplied to x is equal to xy minus 5x equals the difference of y and 5 multiplied to the quotient of the sum of y and 1 and the difference of y and 5 is equal to y plus 1. Our next step is to transpose negative 5x to the right side of the equation. We also transpose y to the left side of the equation. Our equation is now written as xy minus y is equal to 5x plus 1. We now get the common monomial factor of xy minus y. That is equal to y. And the other factor is x minus 1. Then copy the equation and 5x plus 1. To isolate y, we need to divide both sides by x minus 1. The left side of the equation will be divided by x minus 1, and the right side of the equation will also be divided by x minus 1. Y is now equal to the quotient of the sum of 5x and 1 and the difference of x and 1.